Hello, my name is Sophia Sardella, and I'm back again helping you guys do some practice problems for a basic general chemistry class. So for this first video, I'm gonna be focusing on chapter 4. The problem that I chose to focus on in chapter 4 is me determining the molarity of a solution. To do this problem, you are going to need a calculator, a pencil, a piece of paper, and then you are also going to need a periodic table nearby. Once you have all of those, we can start in and get ready to solving this problem. Okay, so now that we're ready, we can start doing our problem. Our problem says a scientist dissolves 8.4 grams of CH2OH in water to make a solution with a final volume of 2,450 milliliters. What is the molarity of the solution? So, the first step we are going to do is write the molarity equation. Molarity is described by using a capital M. Just keep that in mind and don't get it confused with the lowercase m that we use to signify meters. And our molarity equation is going to be M equals moles of a solute over liters of a solution. So once we have that figured out, we can start the steps of figuring out our problem. Usually I like to write out the knowns of the equation and what I defined in the problem. I just like to write them down again just to have another piece of memory and something else to look at as well. So the knowns in this problem are going to be, we have 8.4 grams of CH2OH. And then our second known is going to be that the final solution volume is going to be 2,450 milliliters of a solution. And then the thing that we are trying to find in our problem is going to be molarity. So I just write that down. And once again, it's just something for me to look at. That's just how I like to write it. So now that we have that, we are going to first find the molecular weight of CH2OH, because you are going to need it in your equation when we are moving grams to moles in our conversion factor. So you're going to need to find out the molecular weight of CH2OH. In order for this, I do like to use a little technique where I write them C on a line and H and O, whatever elements you have in a line. It organizes a little better and it's sometimes a little easier to see. So I'm going to write the amount of each element that we have. So I have 1 carbon, I'm going to have 3 hydrogens in my equation and 1 oxygen in my equation. And I'm going to times all of those by the atomic masses of each of those elements. So oxygen is going to be 15.999, and that's going to equal 15.999 because we are multiplying it by 1. The second thing we're going to do is 3 times 1.0078, because that is the atomic weight of hydrogen. And once you get that, put it in your calculator and get 3.0234. And lastly, carbon, 1 times 12.011 equals 12.011. It may seem a little silly to do the times by 1, but like I said, it's a really good organization tool. And next, we are going to have to add these all up to figure out the total molecular weight of the equation. So you're going to do 12.011 plus 3.0234 plus 15.999. And once you put that into your calculator, you're going to get that all those added up is going to equal 31.0334. So now that we have that, we are able to start doing our conversion that we are going to need to do for this equation. So I'm going to take 8.4 grams of CH2OH, and we are going to multiply that by 1 mole of CH2OH over the molecular weight of CH2OH that we found. We found that it is 31.034 grams of CHOH. We do this because when we are, the grams will eventually cancel each other out in this equation, and you'll be left with moles at the end, and that's what we are looking for this problem. So now you're just going to do 8.4 times that by 1. It's still get 8.4, divide that by 31.34, and we put that in your calculator, you're going to get 0.2707 moles. Once again, like I said, the grams do cancel out, and that's why you're only left with moles of the equation. So now that we have that, now that we have our moles, we are able to solve for molarity. So we're going to use our original equation for molarity, which is going to be moles of a solute over liters of a solution. So we have 2,450 milliliters of our solution. And we are going to times that by 1 liter over 1,000 milliliters because we need to get our milliliters to liters of a solution. So once you put that into your calculator, you are going to get that it equals 2.45 liters of the solution. Okay, last step, finding the molarity. We made it this far, we got it. So to find the molarity, we're just going to go back to our other equation, which is moles of a solute over liters of a solution. So you're going to do 0.2707 moles of CH2OH that we found previously when we did our conversion factor from grams going into moles. And once you get that, we are going to divide that value by the 2.45 liters that we found by converting milliliters into liters. And once you get that, you are going to put this into your calculator and do all the math so the calculator does it for you. The final outcome of the molarity is you are going to get the molarity is equal to 0.110. And always just make sure you're using the right amount of significant figures whenever you're doing a problem, just so it's proper when you're doing it. Well, good job, you guys.